Okay, so you are with Western Michigan
University.
Western Michigan University.
Yes.
So, and your name is,
Alamgir Chaudhary.
and you are. What's your affiliation with the university?
Oh, I'm professor there.
So you're kind of exposing these kids to hydraulics.
Yes, they have taken classes with me.
What is the discipline? What is your specialty?
My background is all mechanical engineering.
Okay.
But these students, they are in manufacturing, in engineering management, these two programs.
So why is hydraulics important?
Hydraulics, it's a growing business because of the capacity of hydraulic system to transmit energy and produce large amount of force in a very easy way, in a cost-effective way. Industries are adopting this technology more and more, and as this energy is becoming more and more precious, this global warming and all these issues keeping us under pressure to minimize the energy use. So hydraulic system has that ability to store energy that many other systems cannot do that. So a lot of applications there are resorting to hydraulics for not just conventional advantages of the hydraulic system, also for this energy conservation reason.
So has this project kind of helped you solidify those teachings for these students? I mean, they're actually experiencing.
Partly does, but the way it is, these students are seniors; they're graduating.
Sorry.
So they are hearing these things and doing this near the end of their academic program.
Right.
I feel if we can expose students earlier from the beginning, then we can use this technology more effectively in different curriculum.
Can you tell me a little bit? Go ahead. I'm sorry.
You wanted to?
I was going to say, can you tell me a little bit more about this entry, about your entry?
Oh, okay. This is the design they have come up with. Western Michigan University have been participating in this competition from the very beginning. We participate in every year, and we come up with new design every year.
So this is not building upon a pre-existing design.
No. We have other goals as well for our graduates to achieve. The other issue is we want them to be able to think and solve a problem in innovative manner based on their on the knowledge that they learn in school. And if we tell them to modify the previous one, they are not actually doing much thinking in terms of their design. They are just using their skill to make it function better. Though skill is an important part of their education,
Sure.
but knowledge is also very important. So if they cannot come up with innovative solution of any problem in real life, they will not be successful. So we emphasize on designing a completely new system every year for that reason.
So tell me about this year's. How is
year-
this different?
This year they have this configuration based on 2 wheel and 1 rear wheel. They looked into different types of configuration, what could be suitable in terms of the criteria of the competition, and they decided that based on basic design of a system which is available to them from the previous years, they looked into design issues, how they can accommodate this hydraulic system in a kind of in a bike configuration, meeting all the criteria for the competition. And they decided that this is the best configuration for them.
Which
And
category do you expect us to do best in?
I'm not sure if there will be different category of judgment. There are some other three-wheel vehicles as well.
Well, I think there's
Yes.
not durability, but there's energy efficiency, I think is one of them.
Yes, they should do reasonably well. I cannot tell that they will be winning it. They have tested their system, all the functions, and all the 4 different functions that it's supposed to perform. Yes, they were successful. They work. But in terms of competing with other schools, how well we'll do, we have to wait to see.
Sure. Is there anything you want to point out on this at all that we can focus on, or? I mean,
They
it's
have tried to streamline their design by using this hydraulic manifold, which was not there in early years of this competition.
Okay.
At that time, it was a complex hydraulic circuit. It looked like a cumbersome machine, but they have streamlined the design by using this hydraulic manifold. This manifold is fabricated by industry. Students did not do this. In future, that could be maybe that can be also incorporated in part of the design process, that they should design their own manifold and they should fabricate that if possible.
Right.
We do not have all the machining ability in our lab to fabricate the manifold, but maybe with industrial help, they can design it and fabricate it on their own. If
Is
they
there
do it,
anything unusual about the controls here?
controls are basically to control the function of each of the valves that they have. They have 12-volt solenoid valves that determines which way the hydraulic fluid will flow and which type of circuit will be implemented. So these are being controlled from here.
How many circuits?
There are 4 different circuits.
4 different circuits.
For just normal riding, direct drive from pedal to the hydraulic motor. That's one. Then second is for charging the accumulator. Third is releasing the accumulator, and fourth is the regenerative braking. That means when they slow down the bike, they can capture the kinetic energy to use the motor as a pump and then store the hydraulic pressurized fluid in the accumulator. So that way they are not losing any energy during the braking. So it's kind of hydraulic hybrid system here.
Well, thank you very much for walking me through that.
Thank you.